Welcome to the ProTips video series designed to arm biology learners with background knowledge needed to succeed during upcoming lessons. I'm Professor Workman, and today's pro tips are about scale, or the relative size of things. Scale refers to the relative size or magnitude of things. Very large and very small numbers are difficult to wrap my head around, like in this image. How much is $1 billion? That is an unfathomable number to me because I'm a teacher. But I can imagine a stack of Benjamins. I've held one $100 bill before, so 100 of those would be $10,000. A nice wad of cash that would fit in the palm of my hand. Scale that up, and I think I can imagine $1 million in a pile at my feet. It would be 10 piles, each stacked 10 wads of Benjamins high. It would fit in my backpack. Imagining $100 million, though, starts seeming mythical. Notice in the image that this would stack high on a wood pallet, so you would need a forklift to move it. And $1 billion? 10 pallets, each stacked with 10,000 of the original wads of cash that fit in the palm of my hand. 1,000 backpacks worth of Benjamins. In the movies, bank robbers could never bust into a vault and steal this much cash because they couldn't carry it. It simply wouldn't fit in a getaway car. This is an absurdly large amount of money. But in biology, 1 billion years is a normal thing to think about. Yes, it's an absurdly long time because most humans don't even live to 100. So this video is an invitation to expand your mind and think in a larger than life perspective. This brings us to our first key term, geologic time. Geologic time refers to the deep history of our planet, which geologists study when they think about the ancient formation of rocks, continents, and that first rainfall on Earth that created an epic ocean. This timescale goes back beyond 4.5 billion years, long before life itself began. This number, 4.5 billion years, is difficult to wrap my head around. If every century were a $100 bill, then it would take 4,500 backpacks of cash. Can you picture 4,500 backpacks? And that's not even stacks of $1 bills, that's condensing Washingtons into Benjamins. So this 4.5 billion number is difficult to conceptualize at first. It takes practice. For example, you may have heard of Pangaea, which was when all of today's continents were connected and the rest of Earth's surface was one giant ocean. This was in ancient times indeed, but it started disconnecting just 200 million years ago. So while 200 million years is a long time ago, it's only 200 backpacks. That isn't so long ago within the broadest frame of geologic time, which, remember, extends all the way back to 4,500 backpacks. So the deepest history of Earth is over 22 times farther back in time than when Pangaea broke up. In addition to imagining very large time frames, scale is also useful when thinking about very tiny things. In biology class, you may also be asked to shrink your gaze, zooming in on absurdly small things, smaller even than a single grain of rice, which is about 3 millimeters wide. Some viewers may have watched a cartoon called The Magic School Bus, in which the bus and its riders routinely shrank down to the size of a cell in order to go on adventures inside the human body. In real life, you may literally zoom in on small things like cells using a microscope. The microscopes used in college classrooms zoom in on things as small as 0.2 of a micrometer. At this level of magnification, you can view human cells, like this cell from inside your mouth, This is a cell from the lining of your cheek, and it's about 60 micrometers across. More expensive microscopes can zoom in even further. This coronavirus, which is about 50 nanometers across, was viewed in an electron microscope, shown in the picture on the left. This brings us to our second key term, which is microscopic size. A microscopic perspective allows us to understand the relative sizes of very small things, like a cell. We could alternatively take a nanoscopic perspective, which would zoom in even smaller. Notice the relative sizes of these three small things. The virus is about 1,000 times smaller than a human cell, and the human cell is about 1,000 times smaller than a grain of rice. This means that a virus is 1,000,000 times smaller than a grain of rice. It takes practice to conceptualize these big differences in size. I think of a cell as small, but this microscopic scale puts it into perspective that a virus is that much smaller still. In summary, you learned that scale refers to the relative size of things and helps us conceptualize very small and very large things. You learned that geologic time refers to the vast stretches of history going back over 4.5 billion years to Earth's original birthday. You also learned about microscopic size, which is the size of things that can only be viewed with the help of microscope technology. These are very small things like cells and viruses. Thanks for watching. I hope you found value in this video. If you'd like to share feedback, here is my email address. Good luck in your biology journey.